If my light is blinking, it means there's USB activity. It means that my CPU is on, that my computer is working. Let me see. There you go. So this computer is alive. So guys, this is Juan Corredor from Engineering Room at Services, and we got another repair. We have here a A1502 MacBook Pro Retina 13 inches, 2013. The problem with this computer, with this MacBook, is it's not powering on. Now, why is not powering on? The first thing I see when I connect my charger is I don't have green light. You see? My green light is not present. So we're gonna check why. So on this repair, on this computer, I'm gonna explain step by step why I'm checking that, and I'm gonna explain on the schematic what is doing it, what is working, the way it works, and everything. Okay? Yes, it is. Okay. So we go to our schematics. This is a 823536 logic board. However, I'm going to use 4924. You can see here. Why? Because the 3536 schematic I have is looking kind of weird. Okay, so let's go with PP Bus G3 Hot. We're gonna check PP Bus G3 Hot in R7005. We got R7005 right here. You can see it, right? So we got 12.20. It's a little bit low, but I think it's good. At this point, I'm not gonna test PP Bus S5. I'm not gonna test any of the PP Bus S5. Why? Because I'm not worried about that. What I need to get is my PP3 my Sys1 wire or PP3B42. Not sure. PP Bus S4. It's on the back. This one is more than nothing. So for the trackpad, so I'm not worried about the trackpad right now. Now these lines, these three lines, we need to talk a little bit about these three lines. We have PPDC in G3 Hot ISO. Then if I'm gonna look it back, I won't find it. Just this one. Let me see. That's it. There's no more. You see why? So how can I get to what's the name of this line in the schematic? Well, easy. Instead of looking for the line, instead of looking for this line, I'm gonna look for the IC that is touching the line. So let's check for D7020. D7020 is touching on leg 1 and 2 here, PP18B5DC in ISO. So this line, and I'm going to show you why, they call it two ways: PPDC in G3 Hot ISO and PP18B5DC in ISO. What it could be confusing, because in the schematic they call it everywhere PP18B5DC in ISO, but in the blueprint it's PPDC in G3 Hot ISO. So these two lines are the same, but they call this line in the other two ways too. They call it S5 charge ISO and S5 Vicent. So every time you see any of these three or this one, they are four different names, exactly same path, same line. Okay, that's how Apple does. I don't know why, and I don't want to get deep on that. I'm just explaining how we're gonna fix this logic board. Okay, so that's it. Now, I know PPDC in PPDC in G3 Hot ISO are pressed. Why? Because I need both, so I can have PP Bus G3 Hot. Simple. If I had PP Bus G3 Hot, I have these two lines. But this line is a, let me show you. Let's go with that line. Oh, my bad. So here. Let me show you. So when we connect the charger, we have PP18B5DC in fuse. It's the same. It goes to F7005. We know it's good. Why? Because we have PP Bus G3 hot. And if we have PP Bus G3 hot, it means the PP18B5DC in con or PPDC in G3 hot isol is present. So from this line, you get same line going to Q7010. There's a R7012, R7010, R7011, and this diode, D7010. Pay attention to this all the time, always tested. Okay, when the line hit all this, it creates the line PP18B5DC in isol. And this is the line who goes, if you follow it, look, goes to R7020, pass through D7005. Okay, we have PP Bus G3 hot over here. And then it hits U7090 and we have PP3B42 U3 hot. Now, maybe you're asking why PP Bus G3 hot? If PP Bus G3 hot come from this, why this 705 have two different entries? Let me explain you why. Because if you're using the battery, PP18B5DC in con, it won't exist. It will be 0. So in that case, D7005, it will use battery power, PP Bus G3 hot R or PP Bus G3 hot, it will be present. So it can create PP3B42 G3 hot regulator. And we're gonna test it in a bit. Okay, I'll show you this guy. Okay, so now, can we have PP18B5DC in isol, PPDC in G3 hot isol, and still we don't have PP3B42 G3 hot? Yes. Why? Because maybe R7020 is damaged. Simple. Period. So we're gonna check if we have PP3B42. If we don't have PP3B42, I'm gonna test R7020. Now, I'm gonna test PP18B5DC in isol. At this point, I know they're okay, but I want to show you that they are present. Now, why PP3B42 is so important? Because that line hits over here, PP3B42 G3 hot one wire protection to U7001 together with SMC BCAC. Okay, this line is a communication between U7100, let me show you over here, and SMC. The U7100.14, it sends 7700, this one, it sends SMC BCAC okay to U5000 SMC. At the same time, it hits U7005, and if both U7100 and SMC are good, everything is good, it will keep this one in 3 volts and hit U7001, and then on the leg, on the pad 5, it will get PP3B42. Now you guys are understanding, and it will create SNC BCAC okay BCC, this line right here. This line will hit U7000 right here in the top, and when we get U7000, it will send sys1 wire. Guess who? You have 1 second. Late. SMC. And if SMC responds and say everything is back, we have our adapter sense. What's the adapter sense in this case? This is our green light. And that's what we are missing. You guys got it? You guys don't got it, please see it again. I don't think I can explain that anytime again on that way. It was too clear even for me. So back to power analysis. And I've already talked all about this. So once you learn that short part, see the video as many times as you want, now you will understand why you only need to test PP Bus G3 hot and jump directly to PP3B42 G3 hot. So let's go to PP3B42 G3 hot, and we're gonna test it on, let's test it on J6100. Where is J6100? 100. Oh, remember, this is not exactly the same board. We're using a different schematic. So we need to find an easier path. Maybe U4650, yes. R4650, this little resistor here on the top. Right here. And we got nothing. Oh, no, we do. We have 3.42. So my 3.42 is good. So it means that my PPDC in G3 hot, or that resistor that communicates my ISO line to this guy, I forget his name, U7001 is good. No, no. Wait. To U7090, yes. So on this line, I'm checking R7020 is good. Now we have PP3B42, but we don't have sys1 wire. So what I need to check, remember when we got sys1 wire, PP3B42 G301 wire protection is communicating together with the SNCBC OK. It creates this pipe to U7000, and then we have sys1 wire communication, and then we have adapter SEMS. So what I'm going to check if we have adapter SEMS. So let's go to U7000.5. U7000.5. Okay, where is it? Right there. Let me get closer, guys. Let me get closer. Where are you? Let me get, there you go. Now we're gonna test it right here, and we got 0. That's why I don't have adapter SEMS. If I don't have adapter SEMS, I will never gonna get green light. Now remember, guys, we fixed doing reverse engineering. So let's go with U7000 and let's test SMC BCAC OK BCC. Leg 1 is this one. So we're gonna test it right here, and we have a test point here. We don't have SNCBC AC OK BCC. Why we don't have it, we don't know yet. Now we go to U7001. This is U71 over here. This is U71. Okay, U7001. The U7001. Let me get back on track. So, do I have SNCBC AC OK BCC? I think we already tested, and no, we don't have it. No. Okay, now let's check if we have SNCBC AC OK. Leg 2, path 2, I'm sorry. And we got nothing. Is my multimeter good? Yeah, it is good. So we got nothing. But do we have PP3B42? Yes, I think we do. Either? Wait. Let me see. My multimeter working, man? Let me check power over here. Voltage went down to 0.6, so I touched something and I didn't like it. Now let's see what's my power again. I think my charger. When you have problems with PP3B42, when you have problems with sys1 wire or with PP bus, sometimes the charger it gets in a state that it won't give you any power. So you have to remove it from the power and put it back. No. Okay. So I lost. Look. Let's see, it works now. Ah, come on, be serious, man. There's still no green light. Okay. It moved. Only makes me run from this board. Okay, so we're back. We were testing PP3B42 is present here. Yes, it is. Is this one present? Oh, yes, it is. So let's retest everything. Thank you. SNC base CAC, okay. Pad 2. And testing this. Okay. On U701, testing pad 1 and 2, pad 1 and 2. Here, SNC BCAC, okay. Is present. And so now I have this one 100%. It should be present. Oh, that's the one I was testing, my bad. So it is present. So my sys1 wire should be present. So my adapter SEMS should be present, right? Adapter SEMS. And is present. But yes, still I don't have green light. So when you have this situation, what I was saying, when you have this kind of situation, you have PP balls, you have adapter SEMS, sys1 wire, everything is stable and working, you only have one issue, your SMC. Let's check our SMC. This is our SMC. This is, and look. Now let's fix this and let's see if we got our sys1 wire back. If not, we have to change the SMC, or I'm gonna rebut it because I don't have it. Okay. So let me, I'm really interested in which path are these ones. So this is my SMC. No. SMC, and what is this? PP3B42 U3 hot. So it shouldn't be that bad. Because PP3B42 is present. That's weird. Okay, let's fix it and we will see.
I hope I'm not disturbing you here.
Me? No, bro, you're good.
No, I'm trying.
Oh, no, stop it.
This one.
Start to test the other one. It will take, I don't know. Let me finish here.
No, this was my priority. They will come in the morning and they will try test.
Test. That's a good idea. But I need to finish this.
I only have 1 hour.
I know. But it's okay if you want to start to test. Grab a chair. Bring any chair and start to test, and then we will clean them tomorrow morning. No problem. Okay. Now let's clean this. Now we can see the issue, right? So let's fit the pad, put new resistors, and we test everything. I'm gonna change this oscillator too. Okay, so yeah,
With tester.
I always recommend, bro, the bottom. So I always recommend you start with power analysis. The idea of this video is more so for new technicians understand how the green light works. The good thing and the bad thing is there's still a lot of MacBook Airs until 2017 that they use that MagSafe 2 charger. And there's a lot of from 2010, 2011, 2012 until 2015 Remnas and Pros. They use the MagSafe 2 and MagSafe 1 chargers. So I believe there's still going to be a lot of work for those new technicians. But from 2016 and newer, there's not green light. But that's still, you're going to have an idea how Apple works. Apple create their circuits. Oh, what is off?
Thermal paste.
I have thermal paste over here.
Don't need your thermal.
Fuck off. There's new one there. Now my soldering iron is hot. And let's fix those pads. And we should have our device working as new. I hope so. I really don't want to reballing the SMC, but it may request it. It may need it. So let's see.
Do you have external MagSafe?
So what I'm doing right here is changing the there you go. Changing the original soldering paste or I don't know how solder that came with the computer for mine, because mine hit faster than the original. Okay, so what we're gonna need now, we're gonna need another board so we can take the oscillator and the resistor. And I think I only have one similar to that one. I can take those resistor and oscillator for any other model, but I want to take it for exactly the same. It's faster. MagSafe or charger? Charger. Take this one, bro. You only need to go to the schematic and check what the frequency of that oscillator. Just replace. Put another in another board with same frequency and done. And it's like 25. I think that one is 25. Let's check. Actually, let's check. Or 32. That one is 12,000 megahertz. Oh, you guys are not seeing this. So this one is 12,000 megahertz. You see? J5110 is 12,000 megahertz. So I have this one. And which logic board is this one? This is a actually, remember that this is not from the same. This is 3536. So I want to check. I'm pretty sure it's almost the same. So let me search it here very quick. I think it's going to be the same. 12,000 megahertz. So it is the same. Now I'm pretty sure that the resistors are R5179, 10K, and R5180, 10K. So let's check the ones I have here on this donor board. Already, oh, it says 12,000 right there. Now let me check the resistors. And if they're both 10K, we're ready. Not ohms. Oh no, I'm in diode. Ohms. Okay, here we go. 10, 994, 997, both 10 were good. So let's remove this and put it in our board. Run it, bro. You can talk, bro. RAM. I have RAM over here.
And the tester.
¿Cómo de?
Tester.
Tester. Dale un tester a Io, por favor.
Extra. Or I can bring mine.
No. Don't bring it here. Then we can get confused. Okay. Okay. Oscillator out. Let me take the resistors. Now let me check my board. And that's it. That's why I lost my resistors, because I'm using the bad. Let me see if I can find it. No.
Looks it good.
So there's more 10Ks over here. Let me grab this one, R5177. R5177, right here in the corner. And 5178, 10K. Both 10K. So I'm going to take these two. This is a good, man, all my twisters are banned. One, let me take the second. Second one is there. Perfect. Ready, bro?
Can you give me those testing for the volt and ampere?
But those are for just BC ports.
What does it?
Those don't work with MagSafe 1, no. Use the USB thingy. I'll show you. Yeah. If there's no power, no green light, that's what you need to put. No power, no green light. No problem.
You sure?
Yes.
Alright.
It's not giving you light or something?
No light.
Okay. No power. Just put no green light. Done. Well, no power, no green light.
I was just trying to, minimize the work.
No, because there's not too much you can do on that in that model.
Por casualidad vos habéis usado este trackpad del chasis que tenéis ahí y el keyboard.
Probablemente. No te funcionan.
No,
Esa es la computadora, ponerle la falla.
no creo porque mira, no me funciona ni el externo. Ah, ya me agarró el externo.
Okay, let me put the oscillator. Come on. It's coming. It's coming. There you go. Almost. I think I need a little bit more heat. There you go. Okay. Now let's let it cool down a little bit. We will clean it. Okay, so let's clean it. After we clean it, I'm going to resolve a little bit those two resistors. I don't trust 100%
Okay.
where they're connecting. Envíamelo, por favor, envíame un texto. I want to be sure that they are. And I need to dry the alcohol from the camera memory, camera IC, and SMC. Let me check.
Yeah.
Now they're good. So now what we're gonna do, let's test if we have green light. Guess what? We have green light, now it's red light. And now let's see, we have USB. Let me use a tester. If we have, if my light is blinking, it means there's USB activity. It means that my CPU is on, that my computer is working. Let me see. There you go. So this computer is alive. That's it. So again, I saw there was that issue from the beginning, but I used this video just to show you, to explain a step by step how we get that kind of issues here, and the understanding that we have about PP3B42, PPDC in G3 hot, PP18B5 DC in ISOL. Why? Because in the last 2 weeks, I've been having a lot of text from different technicians, friends, and new technicians asking me if this is dead, what they can do to test it. Okay, so that's it, guys. This is one from engineering room. Just a short video how to repair A1502. The real way how I fix it will take 2 minutes. Just check there's something there, attack it, fix it, and done. But it was a good opportunity for me to explain that part. Okay, if you have any question, please, you can text me or call me. You have my phone number in Instagram, website, Facebook, YouTube, everywhere.
USB
and please share, comment, and like it. Okay, see you guys next. Bye.